All right. Lecture homework number 7. Atomic theory, we're focusing on electron configurations. So we really want to know how electrons are arranged around an atom. And you'll have a Google Classroom assignment to follow this one up too. So let's get into it. Electron configurations. Well, for ground state atoms, the electrons always want to pack in as close to the nucleus as they can. And they fill in a certain pattern. The first innermost orbital always gets 2 electrons, then 8, then 8. So we know the ground state electron configuration, the electrons fill in 2, then 8, then 8, then 8. Valence electrons. What are these things? These are the electrons around the outermost shell. It's the last number in electron configuration. So if we were to write electron configurations for these examples, this one would be 2-2467. This one would be 2-8-7. And all I'm really doing is counting the electrons and telling you the locations. 2, then 8, then 2, wow, 16? 2, 4, 6, 8, 10, 12, 14. 2, then 8, then 16, then 2, 4, 6, 7. As you see, as the atoms get larger, the electron configurations also get larger too. 2, then 8, then 16, 16, 7. 2, 8, 16, 16, 7. Okay? So the valence electrons, though, which are the ones of interest, are always the ones on the outside, the last energy level that is occupied in the electron configuration. That's the point of that particular note. Okay? So let's see here next. The kernel electrons. Well, if the valence electrons are all the outside electrons, the kernel are the ones that are on the inside. And again, so if we had 2, then 7, 2, then 8, then 7, 2, then 8, then 16, then 7, then 2, then 8, then 16, then 16, then 7. The kernel electrons, the internal electrons, are all the ones that are not the valence electrons. So there's only 2 kernel electrons in a fluorine atom. There's 2, then 8, so 10 kernel in a chlorine. 2, then 8, then 16, so 26 kernel electrons in bromine. 32, 42 kernel electrons in iodine. So the kernels are the ones at the center. Just like in popcorn, the kernel is at the center of that puffy, puffy, tasty popcorn. So that is the kernel electrons. Funky word here, isoelectronic. It means the same electron configurations. So every ion that exists will have the same electron configuration as another atom. Most specifically, an atom from group 18, which is known as the noble gases. Okay. Electron configurations for ions. So we start with the electron configuration for the atom, and then we add or remove electrons to or from that valence shell. So if the ion is positively charged, it means we've lost a valence electron. So we take the atom, like sodium, and we would remove 1 electron from the valence shell. Or if it's a negative ion, like chlorine forms, we would add an electrons to the valence shell. So instead of having 7, it would have 8. Either way, both of those atoms become isoelectronic with another element from group 18, noble gases. So for excited state atoms, this is when you take an electron and you hop it up with some energy to a higher level, energy level. The electron configuration varies from that normal filling pattern of 2, then 8, then 8. In this type of scenario, you might see something instead of 2, then 8, then 8, that's ground state, because all the electrons are packed in around the nucleus as close as they can get. The excited state for the same atom might be something like 2, then 7, then 8, then 1. So, ITED. You can see how, in this scenario, we took one of those electrons and jumped it up 2 levels and made its own extra little level out there. So, that is what an electron configuration for an excited state might look like. We'll practice that to recognize it really well. So you remember, you got to have a pattern, 2, then 8, then 8, then 8. But if it doesn't fit that pattern, it's probably excited state. Let's see what else we got here for us today. So a substance, let me get my periodic table here. Sodium has an electron configuration in the ground state of 2, then 8, then 1. 2, then 8, then 1. It's sodium, so it's an atom. And we would call this the ground state. Okay. Let's see if we hit up sodium ion. Ooh, electron configuration. We're throwing a tough one at you at the beginning. 2, 8, 7, 3. This does not follow the normal 2, then 8 pattern. So I know straight off the bat that it is an excited state. Now, there's no information in there that tells me it's an atom or an ion, so I'm going to assume that it is an atom. And now, in order to figure out the substance identity, I look at the element, the electrons. The total is 2 plus 8 is 10, 17, 20 total electrons. So if the total of electrons for an atom has to equal the total of protons, that means this is atomic number 20, which is calcium. And calcium looks like, this. It's got a 20 for atomic number and a 40 for atomic mass. Okay, let's try a couple more. Some tricky ones, I think, are coming our way. Cl with a -1. Well, I know it's got a -1 in the top right corner, which means that it is not an atom, but an ion. And the rule says, if you've got an ion, you have added or subtracted some electrons from the electron configuration. And I look at chlorine, the atom is 287 on my periodic table. But now I know that it's gained one more electron because it's a -1 ion. So I can say effectively that the electron configuration is 2, then 8, then 8, because it has one more electron than protons. And we would call this, just because it's an ion and standard state there, 288 pattern fill, that's a ground state. Okay. We practice this a whole bunch, but it's really about pattern recognition and knowing what charges electrons have. 2, then 8, then 6. Well, this isn't 288, but it's not like 2861 either. It doesn't look to me off the bat like excited state. So I'm going to go ahead and say that it's a ground state. And I'm going to say that it's an atom too, because you can't really tell from the excited state or the electron configuration if it's an ion or not, which leaves me having to figure out what element it is. So I total up the electrons. 2 plus 8 is 10, plus 6 is 16. If there's 16 electrons and it's an atom, that means there's got to be 16 protons, which means the atomic number is 16. So it's sulfur, S, with a 16 down there, and the atomic mass is 32. Sulfur. Cool. Let's see what else we got here. Just a few more examples. And we'll practice this one a bunch because this type of question is very common to throw an electron configuration at you and ask you if it's excited or ground. So sodium +1. Na with a +1 in the corner. Well, I know off the bat that that is an ion because it has a charge listed in the top right corner. I'm going to assume that it's a ground state ion because I have no other information to tell me otherwise. So what I do is I look for the electron configuration of plain old elemental sodium, and it's 2-8-1 for the neutral atom. But this is not a neutral atom, it is an ion, which means that it has lost or gained an electron. And this +1 tells me that it has lost an electron. So I'm going to change the configuration from 281 to 2-8. Okay. Let's see what else we got for us here. Hopefully, 267. Aha! I notice off the bat it doesn't follow the standard filling pattern of 2, then 8, then 8. 2, then 6, then 7. So the last number here is out of order. It should fill the second shell before it starts filling the third shell. So I know that off the bat that this is excited. So an electron has jumped up a level or two beyond where it's supposed to be. I'm not sure if it's an atom or an ion, so I'm going to assume that it is an atom. so I can figure out its identity, which means I have to add the electrons together to find out its atomic number. 2 plus 6 is 8, and 7 is 15. So it has 15 electrons, and it's an atom, so it must have 15 protons, which means the atomic number is 15. So that's phosphorus. Phosphorus. Last one, and then we'll move on. The last one, magnesium. So it tells us that we have magnesium, the substance. There's no charges there indicating otherwise, so I'm going to call this an atom. There's no other information here to tell us that it's excited or ground state, so I'm going to assume that it is ground state. And therefore, I look on the periodic table and find magnesium, atomic number 12. And I will just write the electron configuration as presented, 2-8-2. Which means that the first two orbitals, 1 and 2, are filled up before we fill up the third orbital, which means it's filling in the right pattern and we're in ground state. So your Google Classroom assignment is obviously to finish your notes, take a screenshot, upload it, prove that you've done it, complete the online portion of that homework, and then come to class ready to do a page or so in our atomic theory packet. We need the periodic table to help interpret this stuff. So thanks for watching. See you later.